I am Asif Equbal. I am an assistant professor in chemistry. Right now, I am employed in New York University, Abu Dhabi. I'm working on dynamic nuclear polarization, where the aim is to transfer polarization from electron spin to the nuclear spins. Electron spins are very sensitive, but their detection with high resolution is not possible. On the other hand, nuclear spins, their detection is very much possible with high resolution, but they are not sensitive. The idea is to combine the two of them. This combination requires not just instrumental advancement, but also theoretical advancement. So I'm working on different aspects of DNP to have more sensitive NMR in the future. One of the things that, one of the application of my research would be DNP sensing. So I can give you an example. In our body, there are hydrogen atoms, which are basically a small magnet, but those magnets are precessing. So there is a precession that is happening, and this precession is very much sensitive to the chemical environment. So if there is a hydrogen atom in a healthy tissue compared to unhealthy tissue, these precessions would be slightly different. But the problem is the signal that we get from these precession, they are very tiny signal. What I would like to do is amplify these signals so that even if a tissue is there, bad tissue in a small quantity, we can get the signal of these precession from the tissue. My research, I aim to make DNP more accessible to people. Right now, this technique is very much limited to a few labs across the world. With some advancement in how DNP works and development of more cost-effective instrument, this technique can reach to a wider audience. This is something how I would like to contribute to the society to make DNP enhanced NMR detection more accessible to the community. It is very important that DNP gets integrated with NMR because NMR in principle has potential to detect any state of the system. But in practice, NMR always lacks sensitivity. With DNP-enabled NMR, we can tap into systems which right now are practically inaccessible. For example, the studying protein molecules inside the cell, which is their native environment, is something that cannot be achieved with conventional NMR. But with DNP-enabled NMR, we can study protein molecules in a more physiological condition, which scientists at the moment are not able to do without DNP. My future goal is to do quantum sensing using dynamic nuclear polarization. Quantum technology research has got a real boost across the world because people have realized compared to conventional sensing technique, quantum sensing can be a lot more precise and can provide information at the single molecular level. So this is something I want to do with hyperpolarized nuclear spins to sense other molecules at single molecular level or at very low concentration.